loan repayments. So when we borrow a large sum of money, a loan, we usually have to pay it back in small increments, and we call those our loan repayments. So to work out loan repayments, let's consider this little formula that our new money owing is going to equal our current money owing multiplied by our interest rate minus our repayment of the loan for every time period. So let's look at an example. So we're going to borrow $1 million at an interest rate of 6% per annum to be paid back over 30 years, and we want to find what monthly repayment is required to do this. We're after the monthly repayment. So because we're after the monthly repayment, everything needs to be in months. So our interest rate is in per annum in years, so we need to divide it by 12 to give us 0.5% per month. And we have 30 years, which we need to multiply by 12 to give us 360 months. Then just with this interest rate, we'll turn it into a rate by 1 plus 0.5 on 100, which will give us 1.005 to deal with. Now, we said previously, so let's start off with A0 equaling $1 million, where A0 is going to be the money owed at the start. So this is our money owed at the start. Then we're going to have A1, which is going to represent the money owed at the end of the first month. So the money owed at the end of the first month is going to be our money owed at the beginning multiplied by our interest rate minus our loan, our monthly payment. So we can tidy this up a little bit. So we know the money that we owe is $1 million multiplied by our interest rate, which is 1.005 minus our monthly repayment. And that's what we want to find. And that's going to equal A1. So A2 is actually going to equal A1 times our interest rate minus our monthly repayment. But we know A1 is equal to all of this, so we can go ahead and sub that in there. So we get 1 million times 1.005 minus M, all multiplied by our interest rate, which is 1.005 minus M. We can expand this out. So we multiply our 1.005 by both terms. So we get 1 million times 1.005 squared minus 1.005 M minus M. A3, which is going to be our money owed at the end of the third month, is actually going to be our A2 times 1.005 minus our monthly repayment. So we're just doing the same thing over and over again until we can see the pattern. And this is going to be A3 A2 is all of this, and we can sub that in there. So we get 1 million times 1.005 squared minus 1.005 m minus m. That all needs to be multiplied by our rate of 1.005, and then we minus m. We can expand this out to give us 1 million times 1.005 cubed, because we need to multiply out by all three terms now, minus 1.005 squared minus 0.5 squared m minus 1.005 m minus m for our A3. So hopefully now we can see a pattern that A3, and we have a 3 here, and then we're decreasing by 1 with our powers each time. And we need to get all the way to A 360. So that's just going to be 1 million times 1.005 to the power of 360 minus m times 1.005 to the power of 359 minus all the way down to minus 1.005 m minus m. And remember, A1 was the money owed at the end of the first month. So A360 is the money owed at the end of the 360th month. But we wanted to pay all the loan off by 360 months. So that means the money owing at the end of 360 months is actually equal to 0, because that's where we pay it all off. Also, on our right-hand side of the equation, hopefully you can see we've got a common factor of minus m with every term except for the first term. So let's write our first term out. 1 million times 1.005 to the 360. Now let's factorize out our minus m. And we're actually going to reverse the order of these terms at the same time. So when we factorize out a minus m out of this last term, we're left with positive 1. When we factorize out minus m out of the second last term, we're left with a positive 1.005. The second last term here would actually be minus 1.005 squared m. And when we factorize out minus m, we're left with 1.005 squared plus all the way to positive 1.005 to the power of 359. Now we have a geometric series here, which we can sum using our geometric sum formula. So we get 0 equals 1 million times 1.005 to the power of 360 minus m, all outside of. Now, our first term is 1. Our common ratio is 1.005 because that's what we're multiplying each time. And our number of terms, you'd think might be 359, but we've got that extra 1 there. So our number of terms is actually 360. So now we can go ahead and use our sum formula, which is a outside of r to the power of n minus 1 over r minus 1, because r is bigger than 1. So we get our first term, which is 1, outside of our r, which is 1.005 to the power of n, which is 360, minus 1, all over r, 1.005 minus 1. And now all we have to do is solve for M. So let's go ahead and add this whole term to the other side. So we get M outside of, well, times in by 1 does nothing, so let's just get rid of that. 1.005 to the power of 360 minus 1 over 1.005 minus 1 gives us 0.005, and that's going to equal, taking that to the left hand side, so on the right hand side we're left with 1 million times 1.005 to the power of 360. Now we can divide both sides by this bracket, so we're left with M equals 1 million times 1.005 to the power of 360 all over our big bracket of 1.005 to the power of 360 minus 1 over 0.005. We're finally ready to throw that in the calculator, and we get $5,995.51 for our monthly repayment. So what this means is that if our monthly repayment is $5,995.51, we'll pay off the loan exactly in 30 years.